Hello students, let us see some examples on continuous function. First example is let f from R to R be the function defined as f of x is equals to 1 if x is rational and is equals to 0 if x is irrational. Okay. Show that f is discontinuous at each a belongs to R. Okay. Solution. Let A is belongs to R. We know that set of rational numbers Q and set of all irrational numbers are dense in RU. We have already seen definition of dense set. Okay, dense means what? That is Q closure is equals to Q complement closure. Q complement closure means set of irrational numbers. This is equals to RU. Okay. Therefore, for A belongs to R, there exists a sequence of rational numbers Xn and sequence of irrational numbers Yn such that limit n tends to infinity xn is equals to a and limit n tends to infinity yn is equals to a. Why this is? Because set of all rational number and irrational numbers are dense in RU. That's why there exists a sequence of rational number, sequence xn, and sequence of irrational number, sequence yn, such that xn converges to a and yn also converges to a. Call this equation number 1. Now, but in problem we have given that f of xn is equals to 1 and f of yn is equals to 0. Why this is? Because xn is a sequence of rational numbers and we have given that when x is rational, f of x is equals to 1. Because since xn belongs to Q. Why f of yn is equals to 0? Because yn is a sequence of irrational number. We have given that when x is irrational, f of x is equals to 0. That's why f of yn is equals to 0. Okay. Call this because yn belongs to Q complement. Okay. Suppose this is okay. See here. Therefore, apply limit on both sides here. We will get limit n tends to infinity f of xn is equals to 1 because limit n tends to infinity 1 is 1 because limit of a constant is constant. This is not equals to limit n tends to infinity, f of yn is equals to 0. Call this equation number 2. So, from 1 and 2 and sequential continuity. Sequential continuity means what? Continuity this sequential continuity means this is a theorem actually. We have seen at the starting of this chapter, and that theorem is nothing but if f from x to y is a continuous function, if and only if f of xn converges to f of x0 whenever xn converges to x0. Now see here, your xn converges to same limit xn and yn, but f of xn and f of yn are not converges to same limit. Therefore, f is discontinuous or not continuous, discontinuous at a belongs to R. Okay, and this is true for any a belongs to R. Therefore, we can say that f is discontinuous at each a belongs to R. Okay, let us take one more example. Second example, let f from Ru to Ru be function defined as f of x is equals to 1 if x is rational, 1 minus x if x is irrational. Show that f is continuous only at 0 belongs to R. Okay, we have to show that this function is continuous only at 0. Suppose f is continuous at a belongs to Ru. Suppose f is continuous at a belongs to Ru. Okay, since set of real number q and q complement are dense in Ru, therefore there exists a sequence of real numbers, there exists a sequence of rational numbers xn and sequence of irrational numbers sequence yn such that limit n tends to infinity xn is equals to a is equals to limit n tends to infinity yn. Call this equation number 1. Okay. Therefore, limit n tends to infinity f of xn is equals to limit n tends to infinity f of yn. Here our assumption is f is continuous at a is equals to ru. Therefore, by theorem, if f from x to y is continuous, then f of xn converges to f of x0 whenever xn converges to x0. See here, xn and yn are converges to a. Therefore, their images f of xn and f of yn are also converges to the same limit. Okay. Since f is continuous at a. Okay. Limit n tends to infinity f of xn. Limit n tends to infinity f. Here xn is a sequence of rational numbers. When x is rational, f of x is equals to 1. Okay. This is equals to limit n tends to infinity f of yn. Yn is a sequence of irrational numbers. When x is irrational, that time f of x is 1 minus x. So here is 1 minus yn. Okay. So limit n tends to infinity 1 is 1 is equals to limit n tends to infinity 1 is 1 and minus limit n tends to infinity yn. Therefore, 1 is equals to 1 minus a. Okay. So, we will get a is equals to 0. Okay. Therefore, f is continuous only at 0 belongs to R. Okay. Let us take one more example. Third number. Let f from Ru to Ru be function defined as f of x is equals to 0 if x is rational is equals to x square minus 5x plus 6 if x is irrational. If x is irrational. Solution. Suppose f is continuous at a is belongs to Ru. Since set of real number q means set of rational number and set of irrational number are dense in R. Okay. Therefore, there exists dense in Ru means what? Q closure is equals to, that is Q closure is equals to Q complement closure is equals to R. Therefore, there exists a sequence of rational numbers. There exists a sequence of rational numbers xn and sequence of irrational numbers yn such that what limit n tends to infinity xn is equals to a is equals to limit n tends to infinity yn. Okay, therefore here our assumption is f is continuous at a is belongs to Ru. That's why limit n tends to infinity f of xa is equals to limit n tends to infinity f of y. This is by theorem. Since f is continuous at a, by which theorem? If f from x to y is continuous and f of xn converges to f of x0, this is if and only if part, if whenever xn is converges to x0, this is by theorem. Okay, so what is limit n tends to infinity f of xn? Xn is a sequence of rational numbers. When x is rational, that time f of x is equals to 0. So here limit n tends to infinity f of xn is equals to 0. Okay, which is equals to limit n tends to infinity. Yn is a sequence of irrational numbers. When x is irrational, f of x is equals to x square minus 5x plus 6. So here is yn square minus 5yn plus 6. Okay, so limit of 0 is 0 is equals to, here is limit n tends to infinity yn square, limit of yn is a, so here is a square minus 5 into limit n tends to infinity yn, here is a plus 6 is constant, so limit of the constant is constant. Okay, factor of this is 0 is equals to a minus 2 a minus 3. Okay, so we will get a is equals to 2 and a is equals to 3. Therefore f is continuous at a is equals to, or we can just say that 2, 3 belongs to Ru. Okay, let us take one example for homework. Let f from Ru to Ru be defined as f of x is equals to x minus a1 into x minus a2 and so on x minus an, when x is rational, is equals to 0 when x is irrational. Show that f is continuous only at a1, a2 and so on up to an. Okay, solve this example. Okay, we will stop here. Thank you.